Can anybody remind me what an intrusion detection system is and why we need one? Go for it.
An intrusion detection system, without using those words, is how we detect intruders. It'll not just be for like looking for people who are actively intruding onto our network, but it kind of goes a little bit more broader than detecting anomalies, things and devices that are doing things we didn't really specify them to do. Our like endpoint devices shouldn't be talking to all of our servers at once and downloading a whole ton of files. So an intrusion detection system will be find anomalies.
Yes. I think that's an excellent answer. Find anomalies. I was actually thinking of a network intrusion detection system, but I did not specify that. So you gave the more accurate answer. Can somebody tell me what a network intrusion detection system is?
So when a system is trying to, maybe ping server which is not allowed, network so IDS stops it, detects any anomalies in the network, or any workstation is trying to, which doesn't have that many privileges, but trying to go to that server or something. It's network intrusion.
Right. That's a good answer. Yeah. So kind of piggybacking, tying those two answers together, if intrusion detection system looks for anomalies, or as you pointed out, actions that are not supposed to be taken, a network IDS, or intrusion detection system, specifically looks at network traffic. And it looks at the network traffic for those anomalies or actions that are not supposed to be taken. Now, you mentioned that an IDS, or network intrusion detection system, can also be used to block those actions. Depending on the action, you may choose to block it, you may choose to alert on it, or you may choose to do nothing, right? Now, there are two ways to set up your IDS. I'm going to start referring to it as an IDS or an IPS, right? IDS for intrusion detection system, IPS for intrusion prevention system. An IPS takes that idea one step further and actually does the blocking, like you were talking about. So, there are two setups for an IDS IPS. And different softwares will call this different things, but I like to say inline versus LAN tap. The difference there is, let's say you have two devices on different subnets that are talking to each other, right? What you can do is you can put your IDS IPS in between those two subnets, so that all the traffic that goes from one to the other will go through the IDS IPS. That is called inline. The other option is, let's say those two devices, I shouldn't say more commonly, but let's say those two devices are on the same local network, right? And they just talk directly with each other. At this point, there's no IDS that you insert in the middle of it, but you can still have the IDS sitting next to them and listening in on their conversation. Does that make sense? So in the inline way of doing it, your IDS IPS sits in between the two devices. In the LAN tap way of doing it, it will listen in on that connection, but it won't actually be in the middle of it. Make sense?
It will be on the subnet, just one.
Yeah. I would say to be more technically accurate, it would be on the same network segment, usually. Or you could, of course, take traffic from that network segment and forward it to the IDS IPS. Then it doesn't have to be on the same network segment. There are a lot of different ways of setting it up, but the point is you're taking that traffic and you're monitoring it, but not necessarily sitting in the middle of it. Just thinking about that, can you give me the advantages and disadvantages to each? Anybody want to take a stab at that? Go ahead.
For the network intrusion detection system advantages for inline.
Hmm.
Inline, it's between two subnets, right? So
I gave, just to qualify that, I gave the example of two different subnets, but to be more specific, two different network segments. They could be the same subnet, but maybe like there's a switch in between them or something, right? So they're in like different places on the network. But yes.
So the first advantage would be the analyzing traffic, because let's say if the attacker got access to our subnet, or it's in the subnet, it will try to identify any anomaly in the traffic. If that system is not supposed to talk to that system server or workstation, it will detect that. First advantage would be that, and the first disadvantage would be, let's say, if an attacker got access to one of the privileged account or privileged workstation, then they will not mark as an anomaly. So because it's a usual workstation that can be used for uh, communicating with other device, it's one advantage and disadvantage.
So let's talk about the first one first. You said an advantage is that it can see the communication between those two devices. Let's now take the LAN tap example, right? Now, in that example, it's not sitting between those two devices, but it is sniffing the traffic that's going between those two devices, right? So in either case, whether you use inline or whether you use LAN tap, either way, you can see the traffic that's going between those two devices. So it's not really, there's no advantage to being inline for that, if that makes sense. Yeah.
Seems like for inline you would need a physical device, or it'd be helpful, or a piece of software on your firewall or a network switch or something. Whereas LAN tap, you would also probably have a device, but it could be a virtual machine on a server that server's already hanging out in your network.
Another good thought, also not quite right, because I could, for example, and actually we're going to be using Suricata in the LAN tap configuration. I could create a virtual machine that just grabs all the traffic from the other machines that are communicating, right? It doesn't necessarily have to be a physical device that's tapping in. It could be a virtual machine.
Oh, yeah. But then could you have an inline as a virtual machine?
Oh, sorry. Yes.
Yeah.
You can have an inline. Right. Sorry. You said the inline can't be a virtual machine. The inline can also be a virtual machine. Let's say it had two subnets on different Linux bridges, for example, in Proxmox, right? Or let's say I had two different Linux bridges in Proxmox. I could have a Suricata VM or virtual machine that routes traffic between those two bridges. So it can be a VM as well.
If this VM goes down, if it gets taken out, your network is now down as well. This link doesn't exist.
That is a fair disadvantage.
Okay.
Yes.
Then I am getting it.
You are getting that. Yeah. So one of the that's a good point. One of the disadvantages of inline is now if that IDS or IPS goes down, now suddenly those two different network segments can no longer communicate with each other. Mm-hmm. That's why it's important if you're doing the inline setup to have a backup in the event that happens. Any other guesses before I give you my answer?
The advantage or disadvantage, anything, right?
I think that is probably the biggest disadvantage, but I'm sure you could think of other ones. But I'm looking for why would we then use an inline as opposed to a LAN tap?
In my head, I like it more because I know for sure I'll catch every packet and every piece of data flowing over the network, where if your LAN tap's network interface is overloaded, it will lose things, yet traffic will be allowed to go through. This is more at the rate, like if it's a gigabit network machine, it'll, like, if there's a bottleneck, packets will be lost, and both devices will have to retransmit those to then still be
Yeah.
caught. So this seems guaranteed.
I do like that as well.
So I have one question.
Uh-huh.
For the LAN tab, is there a virtual machine on the subnet that is, acting as a IDS or IPS?
Yes.
Okay.
Yeah.
The biggest disadvantage would be if attacker got hold of that machine, and it can disable broadcasting. Of,
Yes.
What do you say that? It's a term that it listens to all the traffic on the network. It starts with P. I don't remember the name.
I'm not sure. But if you're saying like a disadvantage might be that if it's on the same subnet, an attacker might be able to access it.
Yes.
Well, the way it's typically set up is that the interface that it listens on, which is connected to the subnet or the internal network, right, or whatever network segments it's listening to, that interface is in what's called promiscuous mode.
Yes.
So, that's the P word you're looking. Yeah, okay. So it doesn't necessarily have an IP address assigned to it, and you can't access it, if that makes sense. It's only listening.
Okay.
So that doesn't really pose any risk. Typically, the IDS would be also attached to another defense network, and it would have an IP address, and you'd be able to access it.
Let's say if an attacker is in the network and it changes legit MAC address of one of the machines, and imitate that MAC address with the attacker's machine, then IDS or IPS wouldn't be able to detect that anomaly, because it's a machine which is regularly using trying to talk to the machine.
Yeah, I mean, if an attacker does MAC address spoofing or pretending that they have a different MAC address than they actually have, no matter which setup you have, it would fool it in the same way, right? Like if you had the inline setup, if the traffic is coming from, to use Lucas's diagram, if the traffic is coming from this computer and going to this computer, right? And you change the MAC address, it will see it. You change the MAC address of an attacking machine to match this, right? It'll look like it's coming from here. Same thing with the inline. If you're here in the network and you change your MAC address to this, then it will look like it's coming from there.
Is it a disadvantage?
So I would say neither advantage nor disadvantage, because it works the same in both cases.
I think we
Oops.
Okay.
Good. You
Yeah,
muted.
double
You are
check.
muted. Okay.
And are there many disadvantages to it?
Yeah. So I would say the biggest advantage, we talked about the disadvantage to inline. The biggest advantage to inline is that now you can block traffic. Because with the LAN tap, how are you going to block? Those two machines are directly communicating with each other. How are you going to block any traffic? With the inline, you are in between that connection, so you can choose to drop packets, or you can choose to drop packets basically.
And also, can attacker turn off the promiscuous mode?
Not unless they're able to directly get access to your IDS, which there's really no way to do.
Okay.
No good feasible way to do. I mean, feel free to correct me if I'm wrong about that. But so yes. So I would say the biggest advantage to the inline method is now you can drop packets, so you can block actions.
It's a very good advantage.
Yeah. The biggest disadvantage is now you're creating this traffic bottleneck that everything has to go through this device in the middle. So, of course, if that device gets overwhelmed, or if for whatever reason that device goes down, you need to have some sort of backup plan, right? Traffic is going to be moving more slowly now, right? Because it has to go through this intermediate device that makes decisions on it. Make sense? So that's what I would say are the advantages and disadvantages. Now, when it comes to LAN tap, there are kind of creative ways that you can block traffic in certain circumstances. For example, if it's a TCP connection, the net intrusion detection system that's kind of listening in on that traffic, if it's in the same subnet, it could also send out like TCP reset packets to end TCP connections. So every TCP connection that's made, the way it's closed is one machine will send a reset to the other one, right? And so if the intrusion detection system sends a reset to both machines, that effectively terminates the connection.
Could you repeat
However, that only works for TCP. Yeah, so in TCP, if you want to finish, if you want to abruptly terminate a connection, you can send a reset packet, right? So in the typical flow, let's say an error occurred on one machine, it would send a reset to the other machine to terminate the connection. So the IDS, if it detects something that's bad, it can then send a reset message to each of those machines and kill the connection.
Yes.
Okay, cool. So now that we know the differences, the setup that I'm working with here is the LAN tap. The reason I'm doing that is because, one, it's a little bit easy. Well, a few reasons. One, no network traffic hog that we have to worry about. Two, it's easier for me to set up, you would think, even though it was an absolute pain. And three, all the devices that we're monitoring here are in the same, connected to the same Linux bridge and Proxmox, so they're on the same local network, they're on the same network segment. So it wouldn't make sense for me to separate them out just for the purpose of putting like an inline IDS IPS.
Also, for, as an internal, never mind. I was thinking as an internal penetration testing. It's more common for us to probably plug into a network virtually.
Yeah. And I also want to use this for CPTC. So for CPTC, I don't actually want to block anything. I just want to alert on things. So, yeah.
So earlier we were using Suricata as a different virtual machine, right?
Yes. So I have it set up that way.
Is it an inline?
No, it was LAN tap before and it's LAN tap now. So it is a separate virtual, it's this box right here in this diagram. This is a separate virtual machine that just happens to be monitoring the network, right? Okay. So if I actually look at the IP address information for Suricata, I don't know why my mouse doesn't want to work. There you go. I have this 192.168.113 address on this interface. And if you remember, I'm using 192.168.100.0/24 is my subnet that I have all of the defense infrastructure on. So it has Wazuh and basically just Wazuh, right? So that is where we're accessing it using that IP address, right? And that's how it talks to Wazuh. We also have a second network device interface, I think is the proper term, ENS19. And this is in promiscuous mode. So it can see all traffic, not only traffic that is destined for this machine, but all the traffic on the local network, basically. And that is attached to the same network segment that the devices we're monitoring are attached to. Make sense? So if I were to, for example, I'm already root, so I can do TCP dump. So TCP dump is a packet capturing utility. I can see the traffic that's happening on a particular interface. So if I do interface ENS19, here you can see all of the traffic that is going on that network that I have it connected to. And as you can see, like our 192.168.10.2 machines communicating to 192.168.10.11, right, in this example.
It's just because promiscuous mode is on.
Yes. So if I turned off promiscuous mode, I'm not actually going to do it, but I'll show you what it looks like. Mm-hmm. If I turned off promiscuous mode, it would look like this. So as you can see, I'm not really getting any traffic anymore.
But
I will get some traffic. Like I will see ARP. I will see NetBIOS. I remember when we did our CPTC, we talked about these broadcast protocols like LMNR, NBNS, MDNS. I'll see those, of course, because those are being broadcasted to everybody on the local network. That like 224 address there is just says everybody on the local network. But I will not see, or ending in 255, that's also like everybody on the local network. Mm-hmm. But I will not see traffic that is destined from one particular device to another. Make sense? Now, setting this up in Proxmox was an absolute pain. In case you're interested in learning how to do it, I will tell you how I was eventually successful at doing it. The biggest problem is that even if I set up promiscuous mode on this machine, okay, sorry, let me backtrack. Let me explain it from scratch here. So in Proxmox, the way that you create networks is, if I go to network, you create what's called Linux bridges in Proxmox. And that Linux bridge, you can think of it as like a device that all traffic on a particular network goes through. So if I have, this will make more sense when I explain this. So if I have, like, let's say I have VM1 and VM2. If I connect them to the same Linux bridge, they're considered to be on the same network and they can talk to each other. Make sense?
Even if they are not on the same subnet.
Well, they
just need to be in the network segment but not subnet.
So every machine that communicates with another machine needs to have an IP address and be... Actually, it's a good question. I think yes. Sorry. I think you're right. I could be wrong about that, but I think you're right. Although typically, like, if they're on the same bridge, you would put them on the same network. I've never tried, like, putting one on one network and one on another, but, like, on the same bridge.
So they need not have to be on the bridge if they are in the same subnet, right?
They do. So these bridges are like isolated network segments, basically. So if I put one virtual machine on one bridge, or if I attach it to one bridge, and I attach another virtual machine to a different bridge, they will not be able to talk to each other. The only way that they can talk to each other is through like an intermediate device that is connected to both, like a firewall, for example. Mm-hmm. Make sense?
Yes.
Typically, like, I don't fully know the answer to your question, but typically you would use a separate subnet for each bridge, because that's just kind of an easy way of separating it out, right? So each bridge has a subnet associated with it. And that's kind of what I did here. Anyway, so if we look at server 1, which is one of the machines that we're monitoring, and we go to hardware, you can see that it's attached to VMBR3. So bridge number 3. If I look at Suricata, I don't know if that was my phone or not, you can see that it's, okay, well, we'll pretend that the easy way of setting this up, you would attach it to VMBR3, right? Or you would think intuitively that that's how you do it, right? Because now they're on the same network segment. So far, so good? Now, I assumed that if they're on that same network segment, then if I start passively listening to traffic, I would see traffic for all devices on that network segment. And that's what I initially did. So I attached this to VMBR3. And then here I put this in promiscuous mode. I put this interface, the one that's attached to VMBR3, in promiscuous mode. And then I started monitoring. And I could not see, I could only see broadcast traffic. Does anybody have questions about that? Okay. I figured out, or I learned, that Proxmox actually internally looks at which the MAC address of the destination and routes it from one to the other. So if you're sitting there and listening passively, you won't see traffic that isn't destined to you, even if you're connected to the same Linux bridge. At least that's my takeaway, or that's what I observed. Make sense? In other words, Proxmox, when two machines are trying to talk to each other, like in this LAN tap scenario, Proxmox sees the source MAC address and the destination MAC address, and it will take the traffic from here, it'll look at the destination MAC address, and it'll be this one, so it'll give it straight to that machine. It will not send it to everybody connected to that bridge. It will not broadcast it. Yeah. So
how would Proxmox know the MAC address, the destination MAC address, even without broadcasting it?
Because if you actually look at the traffic itself, like if I were to spin up Wireshark and look at the traffic bytes, every packet that's sent has a source and a destination. If it's like a TCP or UDP packet, right? So that Proxmox is facilitating the communication of all of these machines, right? It has these bridges, and those bridges are like managed by the underlying Proxmox machine, right? And so it looks at that, and it looks at that traffic, and then it routes it accordingly, basically. So how do we get around that to create this kind of tap scenario? Well, fortunately, somebody created this really nice tapping Proxmox VMs and containers wiki page. And they gave me this really complicated, I shouldn't say really complicated, but long script for, I think that's my phone, so let me just turn my sound off. Oh no, my sound is off. Okay. And what this script basically does is it takes one Linux bridge, and it takes all of the traffic going to and from that Linux bridge, and it forwards it to a second bridge. So all of the traffic going to VMBR3, or bridge 3 in this case, right? I could grab that traffic and I could basically forward a copy of it to another bridge. And if I attach that bridge to Suricata, now Suricata can see all of the traffic. Does that make sense? Yeah. Sometimes you hear this called a span port. A span port is like another bridge that has a copy of all the network traffic that you're using just to monitor what's going on in the network. Make sense? So that's how I set it up. And basically it's just these commands, like just copy and paste, but you just change the device. This was like VMDR3, and then the target bridge was VMBR1. So if I replace this with VMBR1, I replace this $I with VMBR3. That's how I did that. Okay. The other thing that I noticed, and I'm not entirely sure why, I have a guess as to why, but I haven't investigated enough to know for sure. When I just do that alone, it still doesn't work. Like, it doesn't forward all the traffic to that new interface, that new bridge that I created. It only forwards the broadcast traffic again. However, if I run TCP dump in Proxmox itself and dump the traffic for VMBR3, that for some reason causes all the traffic to get forwarded. And now I can see all of that traffic in here. So as you can probably imagine, it was a lot of trial and error. The reason I think, this is my guess, I could be wrong, but the reason I think that it works that way is if you actually look at this, what this is doing is it's saying ingress traffic from this bridge and egress, this one's egress traffic from this bridge, send it to my other bridge, right? So if it's only ingress and egress traffic to and from the bridge, TCP dump, my guess, is it like takes that traffic and like feeds it through your loopback interface. This is totally a guess. I could be wrong. But my guess is it feeds it through your loopback interface. So at that point, it becomes egress traffic. But otherwise, that traffic just stays on that bridge and doesn't actually go anywhere. I could be wrong, so I'm not going to bother explaining that because there's no point in explaining it if I don't know if that's right. I'm going to have to do more digging, but I will get to the bottom of it. The point, though, is that I'm just going to keep this running in the background, and it's going to work for now. And now we can talk about actually, this is just a very Proxmox specific thing. If you weren't setting this up in Proxmox, if you just like connected a physical device, like you wouldn't have this problem. You'd just be able to put it in promiscuous mode here. You'd be able to see all the network traffic. That was the biggest problem I faced. Now let's talk about the normal setting up Suricata. So when you're first setting up Suricata, pretty straightforward. They have a guide. Oh, and also I should mention, so Suricata has great documentation. They have this nice quick start guide that talks about setting up Suricata. And Wazuh has their own page on network IDS integration, which talks about how to set up Suricata and how to forward all your logs to Wazuh, right? So you can follow either one. I kind of consulted both and mixed and matched and made it the way I like it. If we look at this installation guide, basically you use apt to install the Suricata package. First you add the Suricata repository because it's not part of the normal like Linux packages. You have to add it as an additional repo, and then you can install Suricata. From there, you have to configure Suricata. So the important, and that's using this configuration file. So in etc Suricata, there's this suricata.yaml. Within that, the biggest thing that you need to configure is like how you want to capture traffic. There are a lot of different options there that I also am not super familiar with, so I'm not going to bother trying to explain them. But the biggest, most important one here is the interface. So this is the interface that you actually want to monitor and capture traffic from. So it's not enough to just put that interface in promiscuous mode. You have to actually tell Suricata, I want to capture traffic from that interface. Make sense? By the way, I put that interface in promiscuous mode with like IP link set promise something. You can look it up. Just like how to put an interface in promiscuous.
Equals to 1, something like that, right?
It didn't even, there was no like equals or anything, but yeah. The gist was you look it up, you run the command, and it's in promiscuous mode. And then, of course, you can find creative ways of getting it to run that command on start if you ever restart the machine. I didn't get that far. I just like ran it, but if I were to reboot it, it would not be in promiscuous mode anymore, I don't think. So I might want to like find a way of making that persistent. But anyway, point is, then you specify the interface that you're monitoring here. Cool. After that, you basically restart Suricata and it's all ready to go. But what makes, so Suricata does a couple of things. It captures traffic, it can capture traffic, and it can alert on traffic that is either anomalous or that is bad, that you define as bad in some way, or evidence of an attack, right? So just like with our endpoints, if you remember when we talked about Aurora and when we talked about Wazuh, we talked about the concept of rules, right? You create rules, and that's how you define what is good and bad. Same thing with Suricata. Suricata has its own set of rules that allow you to define specific traffic that you want to alert on or that you would consider anomalous. So Suricata comes with its own open source rule set. And so I'm going to be working with that, and we're going to see what rules come with Suricata by default. But you can also create your own rules as well, right? So if you just install Suricata following this guide, by default, those rules will be located in var lib suricata rules. And then within this, we have this suricata.rules file. So if I open up this suricata.rules file, this is what Suricata rules look like. You can see it starts with alert. That tells it to create an alert for this. And then what kind of traffic, so TCP, IP, UDP, right? The source and the destination. Message, what you want to consider that traffic, or what message you want to give to the alert that it generates, I guess I should say. And then a bunch of other configuration options that if you really want to get good with it, you can dig into them and learn what each of them do and what each of them mean.
Really cool.
The ones that are important that you should know are SID. So just like in Wazuh, each rule has a unique ID associated with it that you can use to refer to that rule, right? So in Wazuh, when we created rules, like we assigned each rule a unique ID. This SID is the unique ID of the rule in Suricata. So each rule in Suricata also has a unique ID. There's another, I don't know if this one has it, but there's an option called, I want to say, I'm blanking on what it is now, but I'll tell you in just a second. Priority. And priority is, you can think of it as severity. So this is how you define how critical of an alert you get, right? So let's say, in this case, I created this custom rule just to play around with it, but let's say nobody is doing any kind of ping on my internal network, so I know that if somebody does a ping, it must be an attacker, right? So I define ping as really bad. If I see ping, I know for sure it's an attacker. That's a critical to me, right? So the highest priority, or the highest severity alert you can get, is priority 1. And that's going to be the equivalent of like a critical alert, right? Now, the priority can be any number from 1. I think it goes up to like 255 or something like that. So you have a lot of leeway there. But most rules by default are from 1 to 4. Mm-hmm. So you can map that really nicely. Hello, hello.
Hi, sorry for being late.
No worries. So it's really easy to map it, say like 1's a critical, 2's a high, 3's a medium, 4's a low, right? If you wanted to map it that way, right? If that confuses you, like I'll talk about mapping it later, but for now, just know that these priorities go from 1 to 255, but typically the ones that are most used go from 1 to 4, right? So far, so good? Any questions? All right. The last important piece is this revision number. Now, I actually know this from using Snort, and I'm assuming it's the same in Suricata. I did not officially look into this, but at least in Snort, you would update this number or increase this number every time you make a change to a rule. Why is there this number that you have to change every time you make a change to the rule? Well, then, when Suricata is loading in its rules, it can look at the revision number and compare it with what it already has like cached in its memory. Not really memory, but like what it already knows, what it already has configured, right? And if it sees that that revision number has changed, then it knows that it has to actually take a look at this alert and update it in its storage, right? Whereas if that number is the same as what it already has in its storage, it doesn't have to actually like update that alert in its storage. I don't know fully how it works under the hood. I just know that you have to change that revision number. My guess would be like to speed up the process of doing these checks, Like it actually takes these alerts and it converts them to some binary format that it knows how to work with that is much faster. That would be my guess. And that's why you need this revision number to tell it, oh, look, there's been a change to this rule. So reevaluate it. Questions so far? Okay. So now, once we've created our rules, and now that we've installed Suricata, all we have to do is start the Suricata service, and it's going to be monitoring traffic, and we're good to go. So to do that, you would say system control start Suricata. I already have it running, so if I do status Suricata, it's running. All right. So now it is monitoring network traffic, and it is generating alerts based on those rules that we created, right? Where do those rules get logged to? Or, sorry, where do those alerts get logged to? Or where do those alerts, where can you see those alerts, right? Well, if you go to var log Suricata, here we have all of Suricata's log files, right? So stats just gives you some statistics about the kinds of traffic that you're seeing. So if I do like a tail of stats.log, you can see it's giving me like, I don't know, it'll give me like amount of TCP traffic. I'll just print some more lines so we can see it here. Like TCP traffic, UDP traffic, like flow data, that kind of stuff. It's just giving you some statistics. This is useful just to see if Suricata is working, right? And if it's picking up actual traffic. Our alerts, so our main Suricata log is in suricata.log. And this again just tells you like, oh, you've started Suricata, you've stopped Suricata, oh, Suricata ran into an error, things like that would be logged here. Our alerts, the things that we're probably most interested in, right, they are stored to this fast.log. So if I just do tail fast.log, here are all of the alerts that have triggered since I started running Suricata, right? So you can see it triggered on this ICMP traffic detected. And here it gives you the source and the destination IPs, which in this case are IPv6 addresses. And also the timestamp at which that alert got triggered. Makes sense? And then, last but not least, there's this eve.json log file. And so this is going to have all that same information that's in the fast log. It's going to have all those alerts, but it'll have them in JSON format. So remember, we talked about JSON format has these key value pairs. So as you can see, like gap is the key here, 0 is the value. Or here we have like destination IP is 192.168.10.10. This is ugly for me to read as a person. Right? As a person, I'd probably want to look at the fast log that I showed you earlier. But can somebody tell me why JSON is useful?
Because it will remove all the unnecessary things. Like if it's in a key value attribute, we can see things clearly, like destination IP, this, source IP, this. But in the logs, it is so. It is the field is not mentioned in the logs, but in the JSON key value pair, there will be a field so that we can determine IPs and stuff.
I totally agree with what you're saying. So an advantage is that now each value isn't just a value; it has a key already associated with it. Why is that useful? As a person, I mean, like I can look at fast.log and I can pretty much tell what everything is. I don't need to like have those keys there. But why is having those keys useful?
For the people who don't regularly look at logs.
I'd say for the computer, I mean, it'll know everything. It's an object-oriented programming.
Well, I liked when you said for the computer.
Yeah.
Right?
just having everything encapsulated in these objects is way more. For example, if you were trying to parse that text file, it's way harder than it needs to be when we have formats like JSON, which is usually the parsed version. Anyway.
So you're taking this in 100% the right direction, but in the end, where do we want to see these alerts?
Wazuh.
We want to see them in Wazuh, right? Or yes, in your sim scene, whatever you want to call it. We want to see these alerts in Wazuh, right?
I want Wazuh to be able to search them quickly. I want Wazuh to be able to interpret them quickly. It's indexer. We need to go.
Yes. When we take logs from the endpoints or from the machine, we put it in Wazuh. What are the 2 stages that logs go through when they're in Wazuh?
Decoders.
That is stage 1. Yep, perfect. So the first stage is decoding. Second stage is alerting or rules. What is the purpose? What do you do during the decoding stage?
So, in the decoding stage, they remove unnecessary things.
No, I would say the alerting stage removes unnecessary logs.
Okay, so in a decoding, we bring it in the key value attribute pair, field and.
Exactly.
Yes.
So in the decoding stage, you're taking this data and you're assigning keys to values. So, in the fast.log, are there any keys?
Nope.
There are only values, right?
Yep.
So you would have to write the decoder to take each of these things and give it and assign it a key, right?
Mm-hmm.
In the JSON log, are there keys?
Yes.
There are keys, right? So you don't have to write your own decoder because the keys are already defined in the log itself.
So we just have to write the rules.
So you only have to write the rules. So, in summary, this fast log is really useful for us as people to look at it and be like, oh, there are alerts. I can understand this. The JSON is uglier. Like if I were to look at this, I wouldn't right away know what's going on. But when it goes into Wazuh, Wazuh knows how to work with that. Got it. I should do more question. I should do more question answer. I have decided that that's how I know when people know things. Hey, you don't have to answer if you don't want to. I see that look on your face there.
Okay.
Uh-huh.
So we have 3 types of logs: fast, Eve, and Suricata. That's it, right?
Well, there are other logs here that I'm just not as familiar with.
Stats. Oh, okay, stats.
But the like important ones to know are your Suricata log tells you how Suricata is doing and whether it's running, that kind of stuff. Your fast log just gives you your alerts, and your eve.json gives you your alerts in a machine understandable format. In addition, eve.json doesn't only show alerts, it also shows just like your regular NetFlow traffic data. So in Wazuh, like if I wanted to see, oh, there was a TCP connection, maybe it didn't actually make an alert on it, but I would still be able to see that like this machine connected to this machine. It has all of that information.
Which logs are transferred to the Wazuh?
Only eve.json, because it has all of the connection information and all of the alerts.
Does eve.json store its logs indefinitely, for it just keeps adding things to that single file?
That's a really good question. I think so.
Is that probably maybe there's a timeout or?
I think it rotates logs, or at least I think you can set it up to rotate it, so it would take it, compress it, and then start over, but store that compressed back up. But I didn't look into it enough to know for sure. So that is a very good question. Yes, exactly.
Best way to test things. Well, mine was a server.
Oh man,
crashes my entire Proxmox instance again because I forgot to look at it a day.
And I don't think I made a snapshot of Suricata, so I should probably do that before it starts getting out of hand.
Oh, that would be good because then you could just revert snapshot when you want it.
That's what I did with everything else.
Mhm.
All my Wazuhs snapshotted now and everything. So I'm probably going to just do weekly reverts and we're never going to have trouble with it.
That's brilliant because I was just trying to look at how to clear Wazuh logs, and it's just
Nah.
every time
Just do the revert.
that's brilliant because I'm looking at the commands and they're like, oh, don't run, like, you can't just delete the database, you have to run these commands.
Yeah.
And, why didn't people think of this? And then,
I think it's really silly
I give
too.
up. Yeah.
Like, you can't just store logs indefinitely. Like, what do they expect people to do?
Yeah. It was like, well, and then they're like, oh, it was easier if you divided your storage, the storage part of it out to its own virtual machine, so you can allocate its storage. And then I'm like, yes, but I didn't do that.
Yeah.
Anyway.
Yeah, I guess you could put it on a separate partition or whatever, and then just rotate out the partition, or even a separate network attached storage or something.
Mm-hmm.
Yeah.
Its own container, storage containers, and then you create the storage container. It's one idea.
Yeah.
Some people use.
That's cool.
Anyway, this is fun.
Maybe future me that doesn't already. Maybe next year. Now this year I'm just killing all my time setting this up, but maybe next year I'll have it all set up and I'll do more fancy things.
And so stats.log is only useful if Suricata is doing well or not. Or Suricata log.
Yeah, it just generally shows you
The status of the Suricata.
Yeah, traffic information, general stats. So you could see how much network traffic you have going on. I don't even know what all of these are, but if you wanted to monitor how your network is doing as a whole, maybe stats would be useful to you. Or you could use it to see is Suricata working? If these numbers are increasing, which they should be, then that's a good indicator that it's working.
The difference between Suricata and stats would be
in log files. So Suricata just tells you oh, the service has been started. Oh, the service threw an error. Things like that. Whereas stats gives you network traffic information. So it tells you this is how many connections have been made that we've seen, that kind of stuff. Yeah. Now moving over to Wazuh. So, actually, let's go to the Wazuh GitHub really quick. So here are Suricata's. Remember that Wazuh, its default rule set. It has a built-in default rule set that it comes with, right? And we can view that rule set on GitHub because it's open source. So, looking at that rule set, we can see that it already has some rules in place for Suricata. So, if we take a look at these rules, right now, every time we see, in this case, an alert, so any log line that starts with alert, or where the event type is alert, it would trigger on this rule. Make sense? We see event type, we see this. This means beginning of text, this means end of text, but really it's just looking for alert. So if the event type is alert, it triggers this rule. Now, if we go to our eve.json file here, and that's the file that's being forwarded to Wazuh, and I look for alert, and I probably should not have, there's a lot of them, but if I look for, let's just look for alert with quotes, probably, and then let's do tail. Oh wait, tail's gonna get rid of my highlighting, which I want. So it's fine, I'll do that. So I'm trying to show you where it says event type and alert. but I'm obviously struggling to find it. Maybe if I looked for event type, that would
So
be
41
easier.
is a priority, right?
No, it's not. The priority is going to be it's called severity for whatever reason in this log file. I'm not sure what alert is, honestly. But if we do event type, let's see if this narrows it down better. There we go. So you can see how we have different event types. And in this case, the event type is stats. So it won't. So this log line will not match that rule. But if the event type said alert, the log line would match that rule.
Okay.
Make sense? So that's how. Now looking at that rule, so we've matched this rule. And by default, it has level 3. So can somebody tell me level 3 in Wazuh, would that get alerted on?
No.
Would that get alerted on in Wazuh, and would it get alerted on in Discord? There are two separate questions.
It will get alerted on Wazuh, but not on Discord.
Correct. Yep. So the way that we set up Discord, anything that's level, I'm already forgetting now, 12, yes. 12 or higher is going to go to Discord. Anything lower than 12 is not going to go to Discord. We will still get an alert for it in Wazuh, because Wazuh alerts for everything that's, I want to say 3 or higher goes into the Wazuh alerts section of Wazuh.
So below 3 it would go in archives, right?
Yes, so anything that is lower, so like for example, if the level was 0, that would go in archives, but it would not go to the Wazuh alerts section. Nice. So in summer, and then so this would go not to Discord, but we'd be able to see it in Wazuh, and it would say Suricata alert dash, and then it would provide the alert signature. So if I actually took a look at what the alert signature is in that log file, that's basically like the alert description. So for example, like when I wrote my custom alert that was ICMP traffic detected, like the alert.signature would say ICMP traffic detected.
So my question is,
Mhm.
in Wazuh we prioritize, severity by levels, right?
Mhm.
But in Suricata we have priorities. How does that work out? Because
Excellent question.
yes.
So, looking at just this rule alone, how would every alert get treated? I know it's kind of a complicated question.
That's severity.
So, every alert in Suricata would match this rule in Wazuh, correct?
Yes.
Every alert, so Suricata, no matter what severity in Suricata it is, it comes into Wazuh, and because it says alert, it matches this rule in Wazuh.
Yes.
So, in Wazuh, it will always assign it level 3 by default. Just using this rule alone, it will always assign it level 3, no matter what severity we gave it in Suricata. So if I were to look in the logs if I were to look in the dashboard in Wazuh, I would be able to see those Suricata alerts. They would all be level 3, or they would all be level 3.
Mm-hmm.
None of them would be treated as more critical than any others. However, if I were to actually click the arrow to display all of the contents of that alert, right? I'd be able to see within that, it would say alert.severity, and then it would say the severity that we assigned it in Suricata.
Okay.
Makes sense?
Yes, but so it will not trigger in Discord.
Right. So, good. Right. So it won't trigger in Discord by default.
Mm-hmm.
So we have to go in and write the rule to get it to trigger in Discord, right? So, does anybody have ideas for how we would do that or how we would approach that? Walk me through it.
So we need to write a group, and we need to create a childmost rule of it.
So a child, what would be the parent of that rule that we're creating?
Alert dot suricata or something. Alert dot signature.
So, sorry. When we create a new rule, right, we want it to be a child rule, right? And the parent of that child rule should be which rule in Wazuh?
This one, alert dot signature.
Correct. Yes. So we would create a new rule that is a child of this rule, right? And because it's a child, I'm sure you know this, but just to make sure everybody's up to speed here, because it's a child, it will only be so it will look for whether it matches this first, and only then will it try to look at that child rule and see if that matches, right? So it will go through, find this rule first. It will say, oh, the log that I'm looking at matches this. Then it'll keep going. It'll find that child rule, and it'll be like, oh, okay, because it matched this, let's evaluate the child rule. That just makes it more efficient, so it's not evaluating the child rule, like if it didn't already match this. In other words, it's not going to like look at the child rule if it wasn't on Suricata alert in the first place. Okay, so we created that child rule, and what does that child rule look like?
So could you repeat the question?
So you're saying we create a child rule. What does that child rule look like? How do we change it? If you were to write that rule right now, how would you write it?
I would create a group name as an alert.signature. Then I would give a rule ID.
Yes, correct. So it would
levels.
follow.
Then
It would.
levels
Mhm.
under, if it's more, so I would consider more than 3. Rule number 4, rule number 5.
Yes. So everything you're saying is right. So you'd have to create, if you're creating a new rule, you'd have to give it a new rule ID,
Yes.
right? So let's say I make it like, I think I did something like this. The parent of the rule was 86601 in this case, right? 86601 is this rule, and that's the parent of this child rule that we created. Okay, so far so good. Now what logic do we want to add to this rule here? What are we looking for?
Field name.
Okay,
Then event type.
and then what event type do we want to look for?
Alert dot. It should follow alert dot signature theme, right? Alert dot,
So we have, just to write this out, within the alert, we have event type, or actually that's not within alert. That's kind of something. So we have event type alert. This is true for every alert. Within that, we have this alert object, and that alert object contains a signature. And this signature is the description, you can think of it, of the alert. And we also have a severity. So this is what once we've undergone the decoding phase, right, where we take that raw log and convert it into key value pairs. These are the keys that we have access to. We have access to event type, which we know that all alerts are going to have event type alert, right? Then within this alert object, we have a signature. So we can reference this with alert.signature. And we also have a severity that we can reference with alert.severity. So going back to writing our rule here, before we actually start writing this rule, let's talk about our goals. What is the issue with this existing rule that we have here? What is the whole reason that we want to write a new rule in the first place?
Because it will only trigger one rule, one event type, which is alert.signature.
I think you have the right idea and are just getting the words mixed up, but if I could add the words to your idea, every alert in Suricata that comes into Wazuh will be treated the same way by Wazuh, right? It's not going to differentiate between higher severity and lower severity alerts in Suricata, and it's not going to the Discord. So we have two things that we need to do. One, we need to make sure it goes to the Discord. So that means changing the level, right, to be 12 or higher. The second thing we need to do is make sure that it treats each severity from Suricata alert differently, right? So it has to treat a low alert from Suricata differently than a medium alert or than a high alert or than a critical alert, right? So I guess I'll give you the answer here in a way. We're going to have to create 4 child rules: a critical alert, a high alert, a medium alert, and a low alert, right? So let's start with our critical alert here. What is the logic that we're looking for to match? So how do we know that log that we got should give us a critical severity alert?
Looking at the log, if it's so normally if a user uses ping.
Well, okay. So what about that log? So once that log comes in, here are all the different keys we have in that log.
Okay.
Which one will tell us how critical the alert is?
Severity.
Right. Alert.severity.
Yes.
Right? So what I'm going to do is I'm going to look at alert.severity.
Yes.
And what severity is critical in Suricata?
14, 15.
In Wazuh,
Okay.
yes.
Okay. Suricata?
In
Or
Suricata.
1.
1, correct, right? So I'm looking for an alert severity of 1. Make sense?
Mm-hmm.
And you already touched on this, what severity do I want to give it in Wazuh? 15. So I'm going to change this level to 15, right? And then last but not least, when I get that alert in Discord, I want a description of, what we saw. So we add description. And how do I take the description from Suricata and pass it to Wazuh?
Event type.
So that'll just say alert. Then my description will be alert, right? But your signature, right? So signature, in the actual log that we get from Suricata, signature contains a description of the alert. So in here, I can use this fancy notation that basically says take the value of this, and I'll say alert.signature. So it'll look at alert.signature, it'll take the value of that. That's what the $ parentheses says. And it'll pass that in here as the description that we get in Wazuh. So then when we actually look at Discord and we look at that alert firing, we'll see that description. Now we have to repeat this process
For all the severity.
for all the severities. So what would I change? Let's say I was doing this for a high severity alert. What would I change?
Level.
Level, what do I want to change it to?
14.
Yep. What's the other thing I want to change?
This priority, the field.
Yes.
Uh,
What would I change that to? No, you're good. I was kind of enjoying it, actually.
I really need water.
yeah, it's correct.
Yeah.
2. Yes, sorry.
Yes.
Yes, you are correct. Yep.
2.
So, if we take a look at what I did in Wazuh, let's say we go to rules. I did all this in 4 hours, fixing Suricata, getting it to work, and setting up these rules in 4 hours before I came, just in the nick of time.
Yay.
We love that. If I go to my rules files and I look at my custom ones, I have this custom Suricata rules. If I edit that, look at that. 12, 13, 14, 15. For each of them, the description is alert signature, and here's the alert severity. The other thing that I did, that's kind of optional, but in case alert didn't have severity 1, 2, 3, 4, because remember it can go all the way up to 255, I still wanted to see it in Discord. I don't expect it to happen, but just in case, I want to be able to see it in Discord. So I also overrode the parent rule here with this overwrite equals yes. So I took this rule that we have here, 86601, right? And I directly overwrote that rule by adding this overwrite equals yes. And I changed it to be level 12, so it will go and it'll pop up in Discord as a low severity alert no matter what, right? And then I just called it an unclassified Suricata alert. Does that make sense how I configured Suricata?
Yes.
The last piece that I didn't talk about yet is how we get those Suricata logs, that Eve JSON log that we saw. How do we get that to go to Wazuh?
OSSEC.
Yes. Do you remember the file name?
OSSEC.log.
Well, log is a log file, but it's actually configuration file.
I think it's in var.
It is, yes. So,
var /OSSEC.
yep. So if we go to var OSSEC etc for configuration, and then the file itself is ossec.conf.
Mm-hmm.
Here you can see I added this line here. And this is saying take the file that's locally on this machine, the var log suricata eve.json file that we were looking at earlier, forward it to Wazuh, and tell Wazuh that the format of this log is JSON. So when it actually ingests that log, it knows to treat it as JSON, and it knows that it has those key value pairs.
And it also tells the Wazuh that we do not need any decoders.
Yes. Yeah, technically Wazuh has its own like built-in JSON decoder.
Mm-hmm.
So if I'm saying it technically accurately, it tells Wazuh to use its JSON decoder. But yes, it means we're not using any of our own custom decoders that we created. Is it helpful to see like the full process from start to finish? Here's the data, take the log, move it here. Now we write the rule.
Mm-hmm.
I guess.
It's detection engineering, right?
Yes. So, well, kind of bleeding into, if we were to compare this to the PowerPoint that I showed the first day, detection engineering is the process of writing these rules, right? So when we talked about writing this rule here, this is detection engineering. When we're talking about like network setup, that I would consider kind of like its own thing. Security engineering, right? Yeah, exactly. So it's a little bit of both. Nice. So now that we've done that, let me see if I can log into Discord real quick, just so that we can see the alerts coming in. And I know I do have to clean up some of these alerts a little bit because these are like constantly triggering. I will clean those up. I will create exceptions for those rules, basically by creating child rules in Wazuh, right? Like we just did. But for now, let's take a look at this. Varlib Suricata rules. If I cat out my custom rules, oh, by the way, one thing I forgot to mention is we also have to define which files to pull these rules from in Suricata. When we're initially setting up Suricata and configuring Suricata, it has to know to look in the suricata.rules file for rules and the custom.rules file for rules. So that is also in the configuration file. So if I say etc suricata YAML, which is the Suricata configuration file, and I look for rules, I'm forgetting what it's called now. It's probably like rules files. No. Man, there we go, rule files. So here you specify the path to where you want to store your rules. So in this case, it's in varlib suricata rules. And then which files you actually want to grab the rules from. So here we're grabbing it from suricata.rules, which is our like base rules that came shipped with Suricata, and this new custom rules file that I created so that I could add my own custom rules. I decided to create it in a separate file just to keep it like logically separated from the built-in Suricata rules.
And also, if you want to add custom rules to Suricata rules, we can, right?
Yeah, I could modify the suricata.rules file too and add rules in there. Absolutely. But then if I were to try to update those rules later on, like pull updates, it would overwrite that file.
Yeah.
And so my changes would be overwritten. Am I recording? Yes, I am recording. Okay, cool. So looking at this rule that I created, and honestly, I went to ChatGPT and I said, write me a Suricata rule that will trigger whenever there's ping traffic. And this is what it wrote for me.
Mm-hmm.
And so as you can see, whenever we see ICMP traffic from anywhere to anywhere, we print out this message, ICMP traffic detected, and we gave it a priority of 1, so that's the highest severity, right? So it's a critical. Now, this rule might not be like actually useful in a real world environment. I'm not saying like you should write this rule is great. I'm just saying here's an example of how you would write a rule so I can show you it in action, right? Question.
Let's say if we modify this rule, we also need to change the rev, right?
Correct. So if I made a change to this rule, I would increase this number here. And that would tell Suricata to reload it, basically. Actually, as you can see, it's 2, not 1. When you first create the rule, you usually put it at 1. The reason it's at 2 is because initially I didn't include this priority, and so it triggered as a like low by default. But I wanted to play around with the priority, so I added that priority there just to like see if I could change it. And so I had to change that rev to 2, from 1 to 2. Yep. So the actual rule that ChatGPT wrote for me was basically this. The only difference was it didn't have this priority and the rev was 1. But I could have gone back to ChatGPT and said, hey, can you increase the priority? And I'm sure it would have. Okay. So let's just to prove that the rule is triggering like after this, I'm just going to put some text here so you know, like if you see anything after this, it just triggered. Let's make sure this is running. So it's running. And if I go to, let's say I go to my server 1 machine. And let's say I try to do a ping. So I'm going to do ping, and I can ping whatever I want. I'm just going to ping another machine in this network. Boom, we have a ping.
Discord.
And now if we look at Discord, look at that. We have ICMP traffic detected. The reason it triggered twice is if you actually look at, so if I take a closer look at this rule in Suricata, take a closer look at this alert in Suricata.
Isn't it going off for every?
So it triggered once on the echo request, and then it triggered again on the echo response. So that is a good question. Why didn't it trigger like 8 times if there were 4 pings? Like,
How did it finale? Yeah.
that's because Suricata kind of like rolls it together. So it saw a bunch of pings in a short period of time. It's like, okay, it wouldn't be helpful to trigger hundreds of times. I'm only going to alert you once. I'm sure you could change that too if you like wanted to modify the rule and make sure it does it every time. But if it sees there's like a time interval, and if it sees that rule like triggering over and over in a small time interval, it's only going to alert on it once. But we got those alerts here, and the other alert that we got, interestingly enough, is a Aurora alert for remote thread creation in uncommon target image. If you were to actually dig into that alert in Aurora, which I did, the reason that we're getting that is because I used the ping utility, and it has like an explicit rule defined for ping being an uncommon, like it's not common for PowerShell to call ping. So that's why we're getting these 3 alerts. Now, if we actually were to open that up in Wazuh, so let's say I go to my dashboards, and if you looked at that video that I messaged like 3 times, please everybody watch this video. If you didn't, that's okay, but you should. But in that video, I showed how to filter down these logs so you find relevant data, right? And as part of that, I already created a filter for Wazuh alerts. So I'm just going to open up the filter that I already created for Wazuh alerts. And if you actually look at what this is looking for, we looked for rule.level is greater than or equal to 12, right? Because we said that 12 goes to the Discord. So greater than or equal to 12, we know we're being alerted on it in Discord. And I excluded anything that has Aurora in the group so that we can kind of treat Aurora alerts separately from just normal Wazuh defined alerts. Right? Now looking at that, I have this Suricata alert, ICMP traffic detected. And if we look at the timestamp on that, it's from 10:24, which is probably when I ran that ping a few minutes ago. If we dig into this, we can see more information about it. So, for example, we can see, remember that data alert severity, that's what made us classify this as a level 15, right? But we can see it right here. It's set to 1. So alert.signature, right? ICMP traffic detected. And remember, we copied that alert.signature to the description. So if I go down here and look at rule description, ICMP traffic detected. And that's what ended up showing up in Discord. We can see all the information about it, like we can see the source and destination. So here's the destination, and here's the source. I'm assuming we'll probably be able to see the request type too, but maybe not.
Maybe you can also see the command as well.
So yes, we can see the command also, but here's my question for you. Will we be able to see the command in Suricata or not?
No.
Where would we see the command?
EDR. Aurora.
Correct. Aurora.
Because it's on endpoint, right?
For that endpoint. Yep. And actually, so that's one place where we can see it. But I would probably look for it in a different place. I'll give you a hint. I ran that command in PowerShell.
Mm-hmm.
What is interesting about that would mean that I can see that command?
Because we are forwarding PowerShell logs as well.
Correct. We set up PowerShell script block logging so that all commands that we run in PowerShell are being forwarded to Wazuh.
Mm-hmm.
So guess what? I already created PowerShell logging on server 1 right here. If I open that up, basically the gist here is I looked for script block text, right? Because that's when the event type, if we look at provider name, Microsoft Windows PowerShell, that's the actual like event type in Windows. Sorry, I'm explaining that poorly. One more time. The way I filtered this out, we know we want PowerShell logs. So the source that I'm getting this from is the Windows event logs, and specifically the PowerShell log. So if we actually look in Wazuh, the provider name for that was Microsoft Windows for Windows event logs. And then we're looking at the PowerShell log. So I filtered down on that. And then within that, I looked for script block logs. So if script block text exists, we know it's a script block log, right? And remember, script block log just means command that you ran in PowerShell. Any command you run in PowerShell gets logged as a script block log. And then all these other filters that I created, sorry, were just to help get rid of noise. So I did one at a time. Like I'd see what logs I had and I'd be like, oh, this is completely irrelevant. Like I see a lot of these. So then I filtered down on it. So for example, I saw a lot of logs where the script block text was $global ? And I'm not entirely sure exactly what that is. That might be something to do with like PowerShell initializing or like something that gets run in the background. But in any case, it wasn't relevant to any of the commands that I ran. So I added a little exclusion there. And so the rest of this stuff is just all different exclusions that I created just so that we only see the most relevant commands. And I also limited this to agent server 1. I also have a separate like filter here that does not limit it to to server 1. But in this case, because most of our tests that we're going to run them on server 1. I also limited it to server 1 so we're not like flooded with too much information. Anyway, doing all that, you can see, look at that, ping 192.168.10.10. The command that we ran shows up right there. And it also gives you the process ID. So now, like in that video that I suggested you watch, we could take that process ID and we could do a whole threat hunting. We could go back and see what else that process did. And we could see the parent process ID. So what process spawned that process? And we could kind of trace the attacker's actions that way.
SOC 101.
Yeah, SOC 101. Yeah, if you took the TCM Security SOC 101 course, they do a lot of like showing how to do that in Splunk. So yeah. And by the way, these columns, I chose to put this script block text column, this process ID column, and agent name column, but I could have chosen any of the data that was here, right? I just chose to add these as columns by clicking toggle column and table, right?
That saves with your search here too.
But it makes it, so that saves with the search as well. Yeah, so when I clicked save on this, it saves both the filters and also the columns. The nice thing about that too is I could add that to a dashboard. So if I have a dashboard like this purple team dashboard that I created, look at that. I can throw all these on a dashboard and now we have all this useful information all in one place. Mm-hmm. So we have all the process creation events. So look, not only when we ran that ping, that also spawned ping.exe, right? So, and basically created a new process. So we can also see that in process creation. We can see it spawned ping.exe and the full command line was ping.exe and then the target. Make sense?
So here it also shows the parent process as well, right? The next.
Yes. So it is interesting to me that, so this is the process ID of this. So, whereas this is the process ID of this. Let me explain. So we have PowerShell, which has process ID 6644. And then when we ran ping in PowerShell, so we said ping 192.168.10.10. That spawned a new process because when you actually type in ping in a terminal or in PowerShell, it searches your path for ping.exe. So let's say it'll look in like C Windows System 32 and it'll be like, oh, okay, I see ping.exe there. And then it'll actually run ping.exe. Now, when it runs ping.exe, that creates a new process. So this is the command that I gave it. it said, okay, I'm going to search for my path. The path is basically all of the folders that it searches normally for commands. And then in one of those folders, so like C Windows System 32, it found ping.exe. So now it knows to run, let's say C Windows System 32 ping.exe, and then it provides it this parameter, 192.168.10.10. And guess what? That's a new process now that's separate from the PowerShell process. And that process has process ID 1148. Got it? So that's why these process IDs don't match up, because this is the process ID of the child C Windows System 32 ping.exe, whereas this is the process ID of the PowerShell command that called it. But if I look at the parent of this process, I don't know if this will actually have the parent or not. I might have to go to a different log for that. But if see parent process ID, look at that. It matches this because PowerShell called ping. Make sense?
Yes.
It's all coming together. Oh, and by the way, remember when I said whenever you run a command, it looks for that executable in your path. Basically, it has this set of folders that it looks through to see if it can find that exe file to run. Where is that defined? Well, in your environment variables. So if I go to edit system environment variables here, and I look at my environment variables, there's a path for every user on the system, and there's another path for my user in particular. But for each of these, see where it says path, if I edit this, these are all the folders that it will search for an exe file every time I run a command. So for example, if I were to run nmap, I could just spin up a terminal and I could just run nmap. And I could just say like nmap and then the flags that I want to give it.
The parent ID would execute.
It would search through each of these folders and it would find nmap.exe in this folder, and then it would run it. And then it would, like you're saying, create a child process that's going to be nmap.exe that actually runs the command that I gave it. Make sense?
So in threat hunting, they try to find the process ID, then child process ID, then parent ID, and that's how they figure out if it's a malware or not.
Yeah, so you can work a lot of the times you'll get an alert on some already suspicious activity.
Mm-hmm.
But from there, yeah, you can go in and investigate it, and then you work your way backwards. So you might look at the parent of that. And then once you know the parent process, what other commands did that person run? What other things did that parent process do, right? Because maybe it's a legitimate user that just happened to decide they wanted to try pinging something, right? So at that point, you kind of work your way backwards and try to figure out, is this attacker activity, or is this just something that somebody legitimately did, but it triggered one of our rules, on one of our rules. So far, so good. Any questions? Now,
It's all coming together.
yeah. Okay, I have a question for you. Let's say from my Kali machine, I ping 192.168.10.10. My questions for you are, 1, will we be able to see that ping in Suricata? And 2, will we be able to see that ping in Aurora? And then 3, will we get an alert for it? Anybody can answer this.
The ping will come from our Kali.
It'll come from our
Over
Kali.
the bridge to be hitting that. Oh, that 10.10 was our.
It is on the network.
But
Yeah.
on the network, it'll be caught by a Suricata then
Mm-hmm.
as ingress, and when it hits, it'll get an egress as well.
Yep.
And those will go over to Wazuh.
Nice. What about Aurora? Will we be able to see this ping in Aurora?
Is that on the window? No. I don't
No,
think so.
because
Oh,
by
that's-
default, ICMP
So where is Aurora installed?
On EDR. So Aurora is EDR on all the workstations.
Yes. It's installed on the workstations and the servers. Is it installed on this attacking machine that I just plugged into the network? No,
No.
right? I didn't install Aurora.
So
So Aurora will not be able to see this ping command, right? So all of that was to say, if an attacker comes in and plugs in a rogue device to the environment, I can't see the individual commands that the attacker ran because I don't have an EDR agent on the attacker's machine, right? I, however, can see it in the network traffic logs. I can see that that ping happened.
yes.
So that shows you the value of having a network IDS, because there are some situations in which your endpoint may not be able to like pick up the command that we ran in this case as easily. However, Aurora, so that was kind of a trick question, because while Aurora will not be able to see this command, it will be able to see that a ping happened. How will it know? Like, where will it see that the ping happened?
When it hits the device and the network interface on that endpoint needs to respond.
Yes. So once I ping this server, 192.168.10.10, that server does have Aurora on it. So Aurora will be able to see, oh, look, I had incoming network traffic. That was a ping, right? Now, do we have alerts set up for that? I don't think so. In this case, Suricata will be the one alerting on it. But we could definitely create rules in Aurora also to say, if you see like an incoming ping, alert on that as well. Makes sense? So the three places, if I were to summarize this, maybe this will make more sense when I summarize it.
I have one question,
Mhm.
which is unrelated, but so by default, Windows machine does not respond to ICMP pings, right?
The Windows workstations don't, but
Yeah.
servers do.
Okay. Will
So-
that alert if someone using Kali to ping that machine, let's say workstation,
Mhm.
will that alert on EDR?
Well, the way we have it set up right now, no. You could set it up that way, like you could write a rule to alert on it, absolutely. But either way, it's going to get blocked in this case. So you can both, blocking and alerting are two separate concepts. Like you can have something that gets blocked, but you don't create an alert. Like in this case, if I were to ping a workstation, I wouldn't get an alert for it on the workstation, but it would be blocked. You could, on the flip side, you could alert, but not block, right? Like you could let that ping go through, but alert on it like we did earlier. Or you could both block and alert, right? So you could block the ping and also generate an alert. Anyway, the machines that are involved, whenever I do something that accesses a remote machine, like the attacker is sitting on one machine and they're targeting another, like a ping scan, a TCP port scan, a UDP port scan, right? There are there are two devices that are involved. There's the device that they're coming from, and then the device that they're targeting, right? So let's say this is the device that they're coming from. So in my case, it's my Kali machine here. And then there's the device that they're targeting. So in this case, let's say it's that Windows server that I'm pinging. And then when traffic goes from one device to the other, it's also on the network, right? Like that traffic has to travel from one device to the other. So we can pick up that activity in three places. We can pick it up on the attacking machine. We can pick it up as it's traveling from the attacking machine to the target machine, and we can pick it up on the target machine. This applies to any connection where we are targeting a remote machine. Now, when we're picking it up on the attacking machine or the target machine, we have the main place that we pick it up is with EDR, right? because EDR is monitoring ETW, it's looking at our logs, like it will see ideally what's going on each of those endpoints. If we want to know the specific command that the attacker ran, that we could only know by looking at the machine that they ran it on, right? So the attacking machine, the one on the left here. And for that, we additionally have sysmon, which shows process creation, and we have PowerShell logging, which shows any power command they ran in PowerShell, right? So to summarize, last piece, if we want to see this network traffic, if we want to see that ping as it's traveling from one machine to the other, that's where our network IDS and IPS comes in. It can see the traffic while it's on the network in transit. So to summarize, we have the two endpoints that we monitor using EDR. We have the network traffic that we monitor using IDS, IPS. And we have PowerShell logging and sysmon on the source or the attacking machine that can give us the full command that the attacker ran. This scenario works just the way I told you if the attacker is already on one of your machines internally and pivoting from that one to another one, right? So let's say the attacker gained access to an internal machine X and they want to run a ping. Yes, I can see the command that they ran, right? Because they're on one of our machines. But let's say an attacker got in by plugging in a rogue device. Like let's say they walked in with their own device, they plugged it in, and they're running attacks from their own device that they plugged in. That device doesn't have EDR. It doesn't have PowerShell logging or sysmon that we installed, right? It's the attacker's device. So at that point, if I were to update this diagram, you could basically say, look, we don't have anything from here, so we are reliant only on network traffic or the destination, or like EDR on the target, right? Questions?
So, can we see all the commands that attacker ran with the rogue device on the EDR?
Nope, you
No.
cannot.
Only the IP address.
Yes, you will only be able to see the network traffic that they created as a result of the commands that they ran.
Okay.
Yes. So if I ran an Nmap scan, you would be able to see that, oh, look, I'm scanning these ports. And you'd even maybe be able to see indicators of Nmap in the traffic. Like maybe Nmap announced itself when it was doing an SMTP service scan, right? It introduced itself as Nmap. So from there, I could take a guess and be like, okay, the attacker's using Nmap. But I wouldn't have the full like Nmap-pn-p. I wouldn't have the full command as a defender, right? I'd have to take a guess as to what that command might have been based on what the attacker did.
So in the most pen test scenarios, they cannot know which commands you ran.
Yes. So if I'm doing a pen test, it is on me as the consultant to keep track of all the commands that I ran and the times when I ran it. So that if the person that I'm testing, if they notice, oh, something went wrong, and here's the activity that we're noticing, and here's the time that we noticed it, I can go back in to my log of commands and I can say, this is the command that I ran.
So what do you use for, to have those timings and the commands?
As a pen tester?
Yes.
If you use my attacking VM script, it's in there. But I'll show you. At least I think it's in there. This is in the Cyberhawks GitHub repo, I think.
I think you
Attacker VMs. Yeah. So full disclosure, I stole this from NetSpy, but I don't feel bad giving it to you because like anybody could have come up with this. I just happened to steal it from NetSpy. But so I'm not I don't take credit for this. But we're using rsyslog, which is a logging utility, kind of like AuditD, if you've heard of AuditD. Okay. You could use AuditD as well. But rsyslog is nice because you can just define I know I'm going to be running in Bash. So, in Z shell and ZSH. So to my ZSHRC file, which
Okay.
gets loaded every time
Ran commands. Yeah.
whenever you create a new terminal session in ZSH, I added this like pre-command function, and that tells it to run this before I run any command. And basically what this is doing is it's just like logging. It says who I'm running the command as, the process ID, the time that'll get logged with it, and then the actual command that I ran, and then the return value. So this is how I do it, and then it logs this eventually to commands. It logs it to var log commands.log, and then if I ever want to like search what command I ran at a specific time, I can just grep and then search for a time, and then var log commands.log, and I have the command that I ran. Of course, we're now talking about like what I do as a pen tester. But if you're a defender, you don't have the commands that the attacker ran. However, a very common way, so I would say the biggest ways for attackers to get in or obtain initial access, one is hardware additions, right, which is where you take a device and you plug it in. But more commonly even than that is social engineering, like phishing a user to download some malware and run it on their machine. If an attacker gets in that way, then they're working through that user's workstation or whatever machine that they downloaded that malware and ran it on, right? And that machine is probably going to have EDR on it. So in that scenario, the defender would have all of the commands that the attacker ran. Does that make sense?
Yes.
So it just depends what the attacker's like source machine is, that what their attacking machine is. Cool. So I'm going to run this ping now after all of that discussion. And what we would expect to see here is we would expect to see the same ICMP traffic detected alert, but we would not expect to see this Aurora alert, right? Because there's no Aurora on my Kali machine. And just to make it clear that like I'm running it after this, I actually have not tested this. So if it doesn't work, I will be very sad. But in theory, it will work. And there we go. We have two alerts from Suricata. Yep. Beautiful. So, now that we've questioned, idea, go for it.
This is like more of a Wazuh thing, but like I'm thinking about network diagramming. Actually, it's been on my mind throughout the whole lesson today, which is like also including locations as to you have your destination and source, and so having a 2D network diagram. And then popping up a little like alert to be like, it was here on this between the connection of these two devices. And then that also, I was thinking about that when you were thinking about the bridges and getting traffic over to Suricata. I think it'd be really helpful for Proxmox to have a built-in network diagram.
Yeah, it's true.
Total tangent, but
what
that's
you
one
could
of
do.
the open source projects I want to develop for Proxmox.
I think we did talk about this like 2 or 3 sessions ago.
Yes. I'm actually now working maybe with a professor, Nick Sultana. He is interested in having me do research for him next semester. And I might try to persuade him to let me develop this whole network topology generator for Proxmox virtual environments.
That would be really cool.
As research for credit. Oh, yes, Matt.
Map will give you like the location in the world, so it doesn't really work as well here. Maybe coordinate map.
Yeah, or maybe like just you could choose map or like an image background. Like maybe you could have a different background.
I'm sure you could do it somehow. I just don't know how.
I'm sure.
But yeah.
Is this still in the recording?
Yes, this is in the recording.
I'm recording.
I hope it's in the recording anyway.
So I was going through this LDAP bind credentials attack.
Mm-hmm.
It's quite nice that I like in CPTC. I think it would be a nice way to introduce LDAP bind credential attack, like LDAP passback attacks and stuff. If we can introduce that.
Oh, a passback attack? Yeah, that would require... Okay, so a passback attack is typically you would do it on a printer or an IoT device. And I really wanted to like get a printer's web portal so I could show you like going into the printer and like going into the SMTP settings and doing an SMTP passback. But the problem is none of them are open source. So
not a single printer in the world. I believe it, but I also think
I could not find a good open source one.
That'd be great. That's an amazing opportunity.
So I'd have to write a custom web application. So I probably will, to be honest, write a really basic one so that I can show a passback attack. But it would be cool if I could show it more in context. The other thing I could do is I could kind of just like steal one from a printer that I have access to and just like put it on one of our machines. And maybe I'll do that.
In real life, while doing pen testing, do you usually do pen testers do the passback attacks?
I always try it. So it has the prerequisite is that there's a default password on the printer,
Yes.
right?
Mostly you
So
do have, right?
I would say you're very likely to find the default password on the printer.
Yes.
The second requirement is they have actual credentials hard-coded in the printer for either to connect to the domain for LDAP or to connect to send out emails for SMTP, right? I would say SMTP passback attacks are way more common than LDAP. I don't think I've ever seen an LDAP passback attack, even though in theory I do look for it, and in theory it could be there. But I see SMTP passback attacks a lot.
I want to explore like how SMTP passback attacks work.
It's exactly the same way as an LDAP passback attack. You go into the printer settings, you find the scan and send settings. Then from there, you look at like, okay, where's the SMTP configuration? From there, you change the destination from wherever it's supposed to go to. You change it to your attacking machine, like your Kali machine. Then you click execute test connection, and then you run responder on your attacking machine. Then it captures the credentials.
So I wanted to ask how can we also I've learned like how to host a rogue server. So is it similar? Is it integrated with LDAP bind credentials attack?
Yeah. So well, when you host a rogue, what Responder does is it hosts a rogue server. That is exactly what Responder is doing. Hosting a rogue server just means opening yourself up for incoming connections, right? And so Responder, if you look at the servers that it has like an SMB server, it has an LDAP server, it has a SMTP server, a web server. It has all these different servers that it hosts when you run Responder-I and interface, right?
And also it's one of the attacks that we could gain and access to the AD, right?
So it does Responder in particular does two things. And I know we talked about this a little bit during CPTC, but the first thing the one thing that it does is it has all these servers. So it's listening for incoming connections with all these servers. The second thing that it does is it poisons LLMNR, MDNS, MBNS traffic. Those are two separate functionalities that are both in the same tool, right? So, and they often go together. Like if you're going to poison LLMNR traffic, you're going to want to have an SMB or an HTTP server to pick up the credential material that you get from the poisoning, right? But I can turn off the poisoners and only listen if I want to with -A. So if I do responder -A, at this point, all the poisoners, actually, I guess it still does DNS poisoning, but like LMNR and MDNS is no longer poisoning those. It's just listening for incoming connections, basically.
Yeah. Also, the AD module is quite good in try-hacking.
Yes, really I do. That is when I recommend when people are like, I want to learn how to do offensive security, my path for them is always TCM security, the 5-core series, then try Hack Me, the offensive pen testing pathway, which includes the AD, all of the AD networks.
Mm-hmm.
And then just with that knowledge, I did OSCP.
And it's quite good.
It is really good. Yeah, I think so too. Okay, so where are we? And all of that, if you forget, is in the Cyberhawks Discord, by the way. I think we have a Where to Start channel.
Yes.
Where to Start? Oh, look at that. Oh my gosh. Let's say I'm interested in cybersecurity, TCM security. Try Hack Me. Also, Hack the Box Academy is really good.
We love the Where to Start channel.
We do love the Where to Start channel.
When I go to professors' classes at the start of next semester, basically tell everyone to go to this channel.
Yeah. And then I also have the certs by what job you're going for.
BHIS.
That is from BHIS. And I met the people who, during CPTC, we met the people who created that document. That I thought that was cool. They're like, do you guys read the Black Hills InfoSec survival guide? And I'm like, this that I give to everybody is from the Black Hills InfoSec survival guide. And they're like, oh yeah, we wrote that. I'm like, oh my God. Anyway, sorry.
Security world is small.
It is small. So now that I've showcased this, I'm going to remove my custom rule here.
No.
You want me to keep my custom rule?
You're going to comment it out.
I'm just going to comment it out.
Okay.
Yeah. And then whenever I make changes to rules, I have to do system control, reload. I'm already root. I'm just so used to typing sudo. Suricata. Not reload. Oh my gosh. Restart. Sorry guys, my brain's a little fried. I'm not doing a daemon reload. I'm restarting a service.
What is daemon reload?
Daemon reload just reloads the service files. So whenever you make changes to a service file, you have to like reload those service files. So if I were to like modify, if I look at the Suricata service, the actual file that it's running is, or the actual file that defines the service is, I think, this. Gosh. No, maybe not. Anyway, the service file is somewhere on this machine, and if I were to make changes to it, I'd have to do a daemon reload. Anyway, going back to this, so now we're just working with the stock Suricata rules. I'm very curious to see how good they are and what sorts of things we'll detect. One point I want to make before we start scanning is, as you can imagine, well, now that we've talked about this, right? What this or the attacker target scenario that we talked about here makes sense if you're targeting a remote, if the attacker is targeting another machine, right? Like if they're trying to move from one machine to another, either they're doing a scan, they're targeting a service, that's where this applies. However, an attacker may also just have access to one machine and be running commands locally on that machine. Like maybe they're listing local users, maybe they're looking at files locally on that machine. For something like that, there is only one place where we get the data from, and that is from the machine itself, right? So for all of the tests that are scanning related, this applies, right? Because we're scanning another machine. But for anything that's like, let's see if I can use WMIC to run this program, or let's see if I can spawn a new process, all of that is only on that one machine. Make sense? Now, the reason I'm making a whole point in saying this is when we're thinking about where we want to create our detections, our rules, right? For anything that's network related, the easiest, in most cases, place to create that rule is in your network IDS IPS. Why? Because your network IDS IPS sees all of the network traffic, right? So like when we're doing scans, like TCP, UDP, ping scans, those could originate from an actual machine on the network, or they could originate from a rogue device that the attacker plugged in. So the best place to see that would be in the network traffic. And the easiest place to write rules for it would be in the network traffic. So when we are testing out, do we get alerts for TCP scans, UDP scans, ping scans, right? Yes, we could look at the source, the attacking machine. We could look at the target, and we could look at network traffic. But I'm just going to focus on our Suricata. I'm only going to focus on our network IDS IPS because in the end, that's where I would like to write the rule for it anyway, because that'll be the easiest place to write the rule for it. The one kind of exception to this, where we have one machine talking to another machine, but it may make sense to actually look at our EDR, or our logs, I should say, endpoint logs. The one place where the one exception to what I've been saying, the general rule that I've been giving you, is if we're interacting with a domain controller. So for example, if you're doing LDAP queries, or if you are trying to do a zone transfer, or if you are looking up DNS records, things like that, it often makes sense to look at the domain controller. Because, yes, you could detect it in the network traffic, but the domain controller itself, like the attacker would always be communicating with the domain controller when they're doing that, because the domain controller has all that information. It has the LDAP service running on it, right? It hosts all of the DNS records. And so it might be easier to dig through the actual DNS logs and the actual LDAP logs on the domain controller rather than looking at the network traffic and trying to like dissect the packets and pull out the relevant information from those packets. Does that, I know this was like a whole long discussion on like where we look for each attacker action. Does that kind of make sense, breaking it up into those scenarios? The TLDR summary of that is for scanning. It's probably easiest to write the rule in the network IDS IPS. For anything that's endpoint related, like running a specific command or looking at files, it's easiest to do EDR or sysmon/PowerShell logging, depending on how you have it set up. A lot of organizations don't even do sysmon and PowerShell logging. They rely solely on their EDR. So then it would make sense to just do it in the EDR. And if you're looking at LDAP queries or DNS queries or any interacting with a domain controller, then it makes sense to look at the logs on that domain controller. Questions? Cool. So I will quiz you on this as we go along. So hopefully you got it down. So I'm going to do a ping scan. Where, if I were to write a detection rule for my ping scan, let's say I don't already have one, where would I want to write that rule?
An IDS.
Correct. Anybody want to walk me through how to do a ping scan in Nmap?
Okay.
With Nmap, let's say.
Ping scan, just ping scan.
Of a bunch of things, or more?
Yeah, let's say we want to ping scan a bunch of machines. Like an attacker, they want to figure out what machines are online, right?
SN. Ping sweep, no?
It's like dash P.
Yes.
Report. Ping. Probably both. We do
Dash PM. Oh.
I don't think you do that dash p in this case. So SN tells it don't. So SN says I'm only doing host discovery. I don't want you to scan any ports.
Mhm.
PE tells it the way I want to do host discovery is with an ICMP echo request.
Okay, I didn't know this.
You could just do nmap SN by itself. Sure, it would. I don't know what it uses by default. I think it uses like ping and ARP and like top 10 TCP ports or something like that. It uses some combination. But if you want to tell it that you specifically want to do an ICMP echo request, -PE. And then the range that we're targeting, which in this case 192.168.10.0/24. And then we'll save our results to a file just to see like what we get. And anything else that I want? I think that's good. Also, actually, one more thing. I'm going to add -N.
No DNS.
Correct, which tells it to avoid doing DNS resolution, because by default, we want this test to be as clean as possible. When I say as clean as possible, I mean if I'm testing to see if we can detect a ping scan, I want to only run a ping scan and do nothing else, right? By default, if I don't include -N, Nmap will also try to do a reverse DNS lookup on all the IP addresses in this range. So it'll look for the host name associated with that IP address. That would interact with DNS, right? So that is a different opportunity for detection. And so I don't want that to muddy up, like, I don't want to be like, oh, look, I detected that, but really I detected the DNS resolution and not the ping, right? I wanted to try to detect only the ping right now.
Okay.
So that's why I include -N. Later, yes, I will try to do DNS resolution, and I'll see if I can detect that, and that'll be a separate test that we do. Cool. So here are the hosts that we found that are online. This happens to be the domain controllers. This happens to be the workstations. Well, they're not actually workstations. They're servers. So I should say domain controllers and servers. Now let's see. I didn't hear any bubbing, so I doubt we have an alert for it in Discord. But do we have an alert for it in Discord? This one was 10:53, which was a while ago. So I would say no.
We need to write a rule.
The next question is, do we have anything related to that in Wazuh?
Yes.
We're going to find out. So first, let's see if I go to alerts, and let's say I just search for, I'm going to do a fuzzy search for ICMP. And I'm only seeing one thing show up. What's my time frame? That would be good to know too. Last 24 hours. Let's do like last 15 minutes, just to narrow down our results. In the last 15 minutes, I don't see nothing in alerts.
Maybe archives.
The next question is, do I have anything in archives? If I look at the last 15 minutes, I have things, these logs seem to match ICMP, and you can see we do have proto-ICMP. So it looks like we do have that information. Let's just make sure we have the correct source and destination. So it looks like the destination was 192.168.10.83. And the source was 10.10.10.6. So if I look at my Kali machine, you'll notice I don't see 10.10.10.6 here, but I kind of did this, the way I have my networking set up is maybe a little bit confusing, but I actually connected to the VPN from my host machine. And so my Kali machine traffic is going through my host machine. So if I go to my host machine here, I didn't, if you connect it to the VPN on your Kali machine, you would see it there, right? But this is just because I connected to it on my Windows machine. If I go here, look at that, 10.10.10.6. So this is, we are in fact seeing our traffic. So we see this ICMP from here to here. Now let's say I wanted to visualize this a little more nicely. let's pull out, so from these logs, we can pull out the source IP and the destination IP. So if I toggle column and table, and I toggle column and table, and the interesting thing here is I'm only seeing, so I'm only seeing 2 IPs. So that's kind of curious. Another thing I may want to dig into is like, what logs do I have around this time? So I'm forgetting how view. So if I do view surrounding documents, let's see if I have any other ICMP related logs around this time. And it looks like I don't. These are different. Now, what could be happening is it's also possible that Suricata is maybe like rolling up multiple of these pings together and only showing me a few. But maybe if I were to look in Suricata, I'd be able to see all of them. So the next place I'd go to check is, let's see Suricata. Now, I'm not entirely sure where I'd see that. My guess is it would be in var log Suricata, probably in Eve. So let's say I do just like a grep for .10 and let's do like 82. Looks like we do not have that in our logs here. But then the other question is, so then the next question I might ask is, okay, am I actually picking up this traffic in the first place and Suricata is just choosing not to log it? Or am I not even picking up this traffic? So now let's do this. Let's do TCP dump -i ENS19. And let's filter this down to only look for ICMP traffic. So I'm going to use ChatGPT to help me out here. I'll say monitor for ICMP echo traffic. Cool. That looks good to me. It's looking for ICMP type 8, which is an echo request.
Oh, 0 is replied.
Yeah. Now let's see if I rerun this command. It looks like we have echo, echo. So the interesting thing here is I am only seeing echo requests for devices that exist. But I'm not seeing them for devices that don't exist. Now, this leads me to think that maybe Proxmox knows that that device doesn't exist, and so it's responding to it before it even like gets in the network. I'm not entirely sure. But another thing I'm going to try, actually, I have a device. I have a jump box here that's actually sitting in the network, so I can test things being on the local network, and we'll see if maybe I get different results. So I believe I can just SSH directly into it. Do I have a jump box? Let's see. It's probably lab, not LAN. Okay, no. Oh, wait. Sorry. Why did you have to search name server? Now let's see if I have jump box. Okay, I don't. That's fine. I'll use its IP, which I don't remember off the top of my head. but it's 192.168.10.30. Makes sense. Oh man, it's been so long I don't remember what I set the password to. I think I just made a root. Yes, okay. And now, let's see, do I have Nmap on here? I think I did install Nmap. I didn't. That's fine. I don't need to use sudo because I'm root, but it's fine. I'm curious if I run that same command from this box, if I'll have different results. Also, I believe Wazuh is probably picking up my... it looks like Suricata is picking up my apt installation, or my using apt. See, it says apt user agent outbound likely related to package. So that's pretty cool. Look at those default built-in rules coming in clutch. Anyway, now that that's installed, now I have Nmap. Let me try rerunning that command I ran before. This time I'm not going to save results to a file. I'm just going to run it. I also don't need sudo. And just to get a clean capture here. Huh. That's really interesting. Now I'm not seeing traffic for it at all. I did not expect that. But I think it also says that everything is down, so there might be a larger issue here. No, it says host is up. Host is up. I don't know.
Maybe it's not on Proximicus mode. Maybe you turned off Proximicus mode or something.
Maybe I turned off this. Nothing should have changed about promiscuous mode, but... Well, here's a good question. Can I see it from Proxmox? If I try to do a TCP dump here. My filter could also be wrong. Well, my filter shouldn't be wrong because I saw traffic before. ICMP. Let's just do ICMP. Looks like I can't even see it when I do a TCP dump in Proxmox, which is kind of interesting.
Maybe it's not forwarding all the bridges traffic.
Maybe not. Well, the interesting thing is I saw those pings, so I wonder if Nmap, well, it should be doing a ping scan. I don't see why it wouldn't. Let's just try running this with sudo and see if it behaves differently. The other thing I can do is this. Let me grab another. Let's split this horizontally. I'm going to grab a second SSH session. Oh my gosh. Root. Now I'm going to see if I can see those pings coming in locally on this machine. So the interface they would come in on is this one at the 0 at if 91. Do I have TCP dump on here? I do, I think. Yeah. And I'm already forgetting my command. It's lowercase I. Oh wait, ICMP. Silly me. Man, I must be tired. Either way, it's not working. That's strange. We'll probably get more alerts for using apt.
How dare you use
I know, right? Let's just try the loopback interface for now and see if it works at all. Okay. That's what I would expect to see.
So we just write localhost.
It doesn't work that way. You have to specify an actual like interface. There we go. Oh, of course we're going to get all the SSH traffic, but I'm focusing on ICMP. Now let's rerun this ping. That is really interesting. I don't even see the ping when I do a TCP dump on the box itself. I wonder if Nmap is not doing a ping scan. And if it isn't doing a ping scan, what is it doing? Let's do TCP dump, filter, get all traffic except SSH, just to have it be cleaner. I guess I could do not port 22, that's fair. So, this is where knowing your tools is important. Because in this case, Nmap isn't even doing a ping scan. It looks like it's doing an ARP scan. And what is this? 477. Huh, it's like almost doing a port scan here. Wait, this is a...
I use Angry IP Scanner as its own tool for just like sending one ping against it.
That's it. Although this should... Maybe SN is not the way to go. Maybe I have to do... This might answer a ping scan, disable port scan. I'm just curious if this will do anything different. SP. Nope, still is the same thing.
Maybe we could just remove SN.
I replaced it. What if I just do this? Box. What does an actual ping look like? That would be good to know. Okay, it says ICMP echo. I find it strange that Nmap is not doing an actual like ping scan, even though it should be. I have the options, right? I'm not crazy. PE. ICMP echo. So why are you not doing the ICMP echo? Anyway, we could use a different tool. Yeah. Trying to think if there's a good Kali tool off the top of my head. We could alternatively do this. Want to do some scripting? This will be exciting. But I think this was good to show you the process of how you should be thinking about things, right? It's like, okay, this is what I'm seeing. Where am I, or this is what I did. Where am I supposed to see it? Okay, I'm not seeing it there. Why am I not seeing it there? What do I have to check, right? And when you're actually doing a purple team engagement, the reason they take so long is because most of the time is spent troubleshooting. Like the client will realize, oh, wait, we thought Sysmon was set up, but Sysmon isn't actually working. Like we're not getting the data from it. Or, oh, we're not seeing this attack, but we would have expected to see this attack. Oh, wait, does our rule actually account for this, right? So a lot of the purple team, a lot of what we do is just back and forth troubleshooting. Do we see it here? No. Do we see it here? No. So I think this was really good to like show you kind of the troubleshooting process that you would take.